Now that you've had a chance to meet the teaching team, we're going to talk a little bit about what you're going to learn in ENES 102 this semester and how it applies to your engineering careers. Now, I like to start the class off by playing a little game. And the game I like to play is called Name That Structure. So, I'm going to show you a picture, and you are going to name what that structure is and where in the world it is located. Here we go. All right. That is the Empire State Building in New York City. Next place. You guessed it, hopefully. That is the Sydney Opera House in Sydney, Australia. All right, how about this one? Yep, that's the Great Pyramids of Giza in Egypt. What about this? That's the Parthenon in Athens, Greece, the birthplace of democracy. What about this famous structure here? Yep, you guessed it. That is the Eiffel Tower. I've been there a couple times myself. Very, very beautiful place. And how about this? You guessed it, hopefully. Or maybe you recognize it. It's not McDonald's. That is the St. Louis Arch in St. Louis, Missouri. Alright, now let's play a different game. A game I like to call Name That Person. Are you ready? Alright. Who are these people? Well, the first person you probably recognize, his name has something to do with a cookie, I think. Emmanuel Macron, the president of France. The other three guys, to be honest with you, I don't even know who they are anymore. I searched their pictures and put them up there maybe 2 or 3 years ago, and to be honest, I don't recognize any one of them anymore. The answer I usually get in class is that, hey, it's generic white guys. Or it's business professional generic photos, right? Well, to be honest with you, all these people are the leaders, either the presidents, senators, mayors, or governors of all the different locations that I just showed you. What this goes to show you, interestingly enough, is that structures play a very significant role in our lives. When you go and travel to Paris, you don't try to get a picture with President Macron. I mean, that would be pretty cool, but everybody has to go and see the Eiffel Tower. When you go to St. Louis, you don't really care who the mayor is, but you are sure going to go to the St. Louis Arch. As Winston Churchill said, we shape our buildings and then our buildings shape us. Structures last for centuries, millennia, and represent all sorts of things. Not just a place where people go, but they also represent ideas. Structures like bridges and roads connect us together to each other. They bring economy and commerce. Structures like the Hoover Dam provide energy and power to provide civilization with the tools it needs to grow. The Eiffel Tower in Venice and all sorts of architecture can be used to beautify a place and to really define a culture and a people. And structures like roller coasters are badass. If y'all don't know, this picture right here is King de Ka, which is, I still believe, the world's tallest and fastest roller coaster in, of course, New Jersey, my home state. But ENES 102 and structures are not only applicable to things that are static. It's also applicable to all sorts of different things that move. It's more than just buildings. Understanding physics and material science allows you to design an airplane to fly and travel at hundreds of miles per hour across the earth. It also allows you to design and build things like cars that drive on roadways and transport people. As a bioengineer, it allows you to design and build prosthetic limbs to allow people to get on their feet again and to participate even in Olympic events, to do things they were never before capable of doing. It allows you to develop new materials and help people like me play golf better, which you need a lot of technology to do. Now I'm out here on this construction site and by this really cool bulldozer tractor because ENES 102, in my opinion, is one of the most foundational and widely applicable engineering sciences to all sorts of different disciplines, especially my home discipline of civil engineering. And I think this semester you're going to learn a lot of really cool things, regardless what discipline of engineering you're in, that you're going to find are both widely applicable in the real world and also are really, really interesting. Let me show you. So, structural engineering in ENES 102. What is it really all about? It's about understanding physics and forces and understanding material properties. When you combine those two sciences together, you can come together and build really, really amazing things, like the Parthenon, or planes, or spaceships, or new civilizations. If we look at the big picture of this class, we're going to go from the simple material of force vectors and free body diagrams. We'll learn about torque and rotational forces as well. And we'll begin to move in and get a little bit larger and look at 2D and even 3D particle and rigid body equilibrium. We'll then begin to marry in this material properties sciences, and we'll start to learn about stress and strain and how materials behave when subjected to different loads. Later on, we'll begin to apply these things to larger and more sophisticated structures like trusses, frames, and machines. And we'll begin to learn about how larger structures like steel buildings and more sophisticated shapes and geometries allow for even greater structural rigidity and strength. We'll talk about columns and this principle of buckling and how to make sure that things don't fail in the real world. We'll begin to apply all these things to 3 dimensions. So get those 3D glasses ready. You're going to learn all sorts of really cool and exciting things in ENES 102 this semester, specifically in the fields of both physics and material science. In terms of physics, you're going to learn about the forces involved in lifting really heavy loads, both in a linear and rotational sense. You're also going to learn about static systems and how to get a truck like this moving to overcome friction. Similarly, you're going to learn things in terms of material science as well, such as the strength of materials and how their size and shape affects their ability to carry loads. For example, the bolts holding this wheel onto the vehicle. As I was saying, ENES 102 is really widely applicable science, and I think and hope that you have a really good time this semester. In addition to learning about the physics and material science that's applicable to moving things like the tractor that we just talked about, you're also going to learn all the different material that's related to structures that are designed not to move, like this building here. This building here is filled with engineering technologies like beams and trusses to help make sure that the structure stands and remains strong during all sorts of different loading and structural and environmental conditions. Hopefully this semester in ENES 102, your eyes will be open to the possibilities of engineering and all of the different things that it applies to in the real world. And if you're like me, you'll be cursed with seeing ENES 102 material everywhere you go in the real world. And that's how you'll know you're really a true engineer. But really, the course goals are for you to learn physics and material science that are applicable in all of your different engineering disciplines, and to learn the basic skills and principles that'll carry over in all of your courses. Critical thinking, problem solving, teamwork, engineering drawing, building things hopefully, and hopefully you learn and have fun. This is the end of the lecture. If you have any other questions, feel free to reach out in the meantime, but I look forward to meeting you all soon and getting started with class.